How's it going, Algebra 1? Mr. Knight here. We're going to continue on with graphing and substitution. So last lesson we looked at the substitution method. We've already looked at the graphing method. It's where, those two lines are going to intersect, and that point where they intersect, that is our solution. You can also see it with substitution. We're solving for an x and y. So they're pretty related to each other, but you're going to see why in just a little bit. This is actually your homework. I'm going to be working on the odd problems to show examples, and then it's up to you guys to do the even problems. There's a front and a back, okay? So you only have 5 problems to do. I also have my notes handy, my notes on graphing, my notes on changing something from standard form to slope-intercept form, and then my substitution notes as well. So I'm going to be using this as a resource for myself while I go through this homework, okay? In case I forget something, right? So let's look at number 1. Let's take a look at that guy. We're going to focus on the graphing part first, okay? So we have these two lines right here. Now, both of them are already written in slope-intercept form. They already look like y equals mx plus b. So I don't need to change them into y equals mx plus b. They're already there. Compare that to something like, I don't know, like number 2. Both of these guys need to be turned into slope-intercept form, okay? So if we're back here, my notes tell me I'm going to start at 0, comma b, so whatever this b is right here, and that'll be my first point. And then from there, I'm going to use my slope, my rise over run, from that point to generate additional points. Okay, so let's see what that looks like. I'm going to start this first equation. Y equals x plus 6. So I know that my first point is going to be at 0, comma 6. That's where I'm going to start. So I'm going to start up here at 0, comma 6. And now I need to use my slope. Well, my slope in this case as a rise over run, well, there's nothing in front of it. It's just a 1. And if I want to make that a rise over run, I could just put a 1 underneath that. Yikes. 1 and run. Huh? That is dangerous game right there. Okay, so now I can go up 1 unit and to the right 1 unit. And go up 1, right 1, up 1, right 1. And I can keep doing that. I could also go the other way. I can treat this as a negative 1 over a negative 1. A negative divided by a negative is a positive 1, so I get the same slope. Let's go down 1 to the left 1, down 1 to the left 1, down 1 to the left 1, and we have a pretty good idea what this guy is going to look like now. Let's go ahead and graph the other one. This one we have y equals negative 2x minus 3, so my first point is going to end up being 0, comma, negative 3. And my slope as a rise over run, if it's just negative 2, I can write that as negative 2 over 1. So let's go ahead, let's plot 0, comma, negative 3, that's down here. And now for my slope. Well, my slope is down 2 and to the right 1. Down 2 and the right 1. And if I keep going that way, that's great, that's well and dandy, I'm graphing it correctly, but I really want to go this way. That's where the lines are going to intersect, so I'm more interested in that. So instead of doing it like this, well, I could represent it with my signs changed. I could make my 2 positive, and I can make my 1 negative. So now I'm going up 2 units, and I go to the left once. Right? I go up 2 units and the left once, up 2, left 1, and there we go. It gives me a really good clear picture of where this graph, where these lines are going to intersect, and it looks like they intersect at this point right here. So that is negative 1, 2, 3. Comma 1, 2, 3. So this is negative 3, comma 3, and that'll be my answer. I'm going to go ahead, I'm going to record my answer right here, okay? Because now I want to see, all right, how does this work with substitution, okay? I should get the same exact thing for my x and my y, okay? So let's recall substitution, right? Substitution is a lot of like playing with one variable, figuring out what that is, and then plugging it into the other one. So our first step would normally be to take some kind of equation and rearrange it so we get x equals or y equals, right? That's kind of our step 1. Take an equation and solve for x or y. Well, it looks like both of these are solved for y which is great. Okay, so I'm going to take this first equation, and I'm going to take its y equals x plus 6. I'm going to take that x plus 6, and I'm going to put that in over here for this y. So I end up getting x plus 6 equals negative 2x minus 3. So now I just need to solve for x, right? Okay, so I have like terms right here. So it doesn't matter. I could go ahead. I could subtract x over here and then subtract x here, or I could add 2x here and add 2x over here. I'm going to go ahead. I'm going to add 2x to both sides. I'm going to end up with 3x plus 6 equals negative 3. Can't forget the negative. Now it's a two-step equation, so I can get rid of the times 3 or the plus 6. Always get rid of the plus 6 or the subtract. Whatever you're adding or subtracting, get rid of that first. It's easy to get rid of it because all I got to do is do the opposite, which is subtract 6. I do it to both sides. So I get left with 3x equals negative 9. And now I can deal with that times 3. I can divide both sides by 3. The opposites over here will cancel, so x will equal negative 9 divided by 3. X is equal to negative 3. And that is a good sign. That means I did it correctly, right? So my x's are going to match up. Now what I can do with this x equals negative 3, I can plug it into either of these equations. Pick the easier one. I'm going to pick this top one. So y equals x plus 6. I'm going to replace that x with negative 3. And if I do that, I end up getting y equals positive 3. And there we go. I end up getting this answer, which is sweet. My job is done. Okay. So what you're doing on your homework is you're first graphing them, seeing where they cross. You get that point, right? Then over here, you want to see by substitution if you can get your x and y to equal those. Okay. If you do that, you've done it correctly. If you didn't do it, double check your work. Okay. This is all good to go. You can write your negative 3 comma 3 over here as well for that part of the answer. Okay, and then you have your answers right here. Okay, let's go ahead. Let's look at number 3. Let's see another example. All right. For these two equations, before I start graphing, is one of them in standard form, or is both of them in standard form? Yes, just by looking at it, right? I don't have y equals mx plus b for either of these two, so I got to change them up a bit. I'm going to start with the 2x minus 3y equals negative 12. I'm going to change that guy up. And I'm going to refer to my notes. Again, if I have something that looks like ax plus by equals c, right? So like this 2x minus 3y equals negative 12. What I can do is I can subtract or add, depending on what the sign is. I could subtract or add ax to both sides. And so I would end up, if I do it with this one, I'm going to subtract my ax, in this case 2x, from both sides. So those will cancel there. I'm going to be left with negative 3y equals, I want my x to come first, so negative 2x minus 12. Next thing I do is divide everything by b. Well, by b right here. So after I subtract the ax, right? So when I divide everything by b, I'll end up getting y equals mx plus b. So I'm going to divide everything by negative 3. And we're going to simplify, right? So these negative 3's will cancel. I'll be left with y equals negative 2 over negative 3. That's just a positive 2 over 3x. Negative 12 divided by negative 3, that's a plus 4. And there we go. I have that guy as my first equation. And for the second equation, just for the sake of time, this one's not too bad anyway. I'm just going to subtract x over, divide everything by 1, so I'm going to be left with the same thing. So I'm going to get y equals negative x plus 9. And now I can graph these guys. If I start with this first equation, my first point is 0, 4. So 0, 4 is going to be right up here. And my slope is rise over run of 2 over 3. So I'm going to rise up 2, I'm going to go to the right 3, up 2, to the right 3. I'm going to go the other way. I'm going to make both negative. So I'm going to go down 2, left 3, down 2, left 3. I should have a pretty good idea of what this line is doing. Brings us to the second equation. 0, comma 9 should be on my line. 0, comma b, right? That's our b. So 0, comma 9 is up here. And now I have a slope of negative 1 over 1, right? So I'm going to go down 1 and to the right 1. And if I keep going that way, I'll end up getting my lines that intersect, so that's a good idea. Down 1, right 1, down 1, right 1, down 1, right 1. Yeah, they intersect right here. So before I make my line, I'm going to count that. That's going to be 3, comma, looks like 6. 3, comma 6. And that would be my solution to that guy right there. Let's put a line through there. We are good to go. Now let's try the substitution method. Let's see if we can get that to match up. This is 3, comma 6, right? So again, I want my x to be 3, my y to be 6. Let's see if we can get that to happen. Now, for step 1 of substitution, do we need to do it? Do we need to take an equation and solve it for a variable? Yes, we do. We don't have like x equals stuff. We have x plus y equals 9. And that is actually probably the easier one to move and get rid of, right, and change around. So I'm going to change this guy to x equals, and I'm just going to subtract y from both sides and get 9 minus y, like that. So now I could take that x, and I can plug it in for x in this equation. Let's do that. So 2 times, well, x is that entire thing. It's 9 minus y. And then that's minus 3y equals negative 12. Once again, we got something on the outside by parentheses. I am multiplying this 2 to both of these terms. So I get 2 times 9 is 18. 2 times y is 2y. So 18 minus 2y minus 3y equals negative 12. Let's go ahead and combine the y's because they're like terms. Negative 2 minus 3 is negative 5y. And what's left is 18 over here, and that equals negative 12, right? So now what I can do is I have a choice. Do I divide both sides by negative 5, or do I subtract by 18? I'm going to subtract by 18. It's the easier thing to do first. I'm going to move this guy up here. When I do this, I get negative 5y equals negative 30. I divide both sides by negative 5, and I end up getting y equals 6. Which, once again, that's a good sign. That means I'm getting it correct. Now I take that y equals 6, and I can plug it back into either of these equations. I'm going to choose the easy one. I'm going to do x plus y, which is now 6. X plus 6 equals 9. Subtract both sides by 6. X is going to end up equaling 3. And I am done. Okay, that guy is finished. Sweet. Let's see one more example real quick before I let you guys loose. Okay, let's look at number 5. Take a look at number 5. Really, the only one I need to change up is the second equation. It's not written in y equals mx plus b. So let's go ahead and let's do that. Again, I'm going to subtract both sides by 6x. Then I'm going to get negative 3y equals negative 6x plus 12. Let's go ahead and divide everything by negative 3. And I end up getting y equals 2x minus 4. Okay, 2x minus 4. And so that is now my equation for that guy. And if you notice something interesting, that's the same as this equation up here. Y equals 2x minus 4. So if my equations are the same exact thing, how many solutions do I have? I have infinite. I have infinite amount of solutions, it turns out. So before I even graph anything, I have an infinite amount of solutions. So that's weird. I wonder what that looks like for substitution. That's kind of odd. Let's go ahead and graph them. And by them, I mean it, right? We have 0, negative 4 as our first point. That'll be right down here. And now I have a rise over run of 2 over 1. So I'm going to go up 2 over 1, up 2 over 1. And I'm not concerned where these lines intersect. They are right on top of each other. They're the same exact line. All right, so how does x comma y, because that's how we write our solutions, correspond to infinite solutions? That's weird. Let's take a look. We actually haven't seen this yet. It's a good thing we're doing it, right? Again, take an equation and solve for x or y. y is solve for. So I'm going to take 2x minus 4 and plug that in for y right here. 6x minus 3 times the quantity, 2x minus 4, equals 12. And let's go ahead, let's distribute this 3 to the 2x minus 4. So I end up getting 3 times 2 is 6x. And then this is going to be negative 3 times negative 4, so that is plus 12 is 12. All right, so the 6x minus 6x, that's 0. Plus 12 is 12, right? So 12 equals 12. But we don't have a variable at all. We don't have a variable. We don't have x equals or y equals. Turns out, when you get something like that, that means this is infinite solutions when it comes to substitution. Kind of something we didn't see before, right? And so we're going to see more of this as we go, and kind of help you guys out a little bit more in case you run into it. You may, let's say you get something like 3 equals 4. Yeah, no, that's not true. That's not true. But if you do get a contradiction like that, where that is not true, that is no solution. Okay? Obviously, this is the answer for this guy, but in the future, that means no solution. Okay? So you might run into that if your math is like, whoa, whoa, whoa. So if you're like thinking you're doing something wrong, you might not be doing something wrong, right? But for the most part, you'll end up getting stuff like x comma y. But not always. Not always. Okay? This is Mr. Knight signing out. Good luck on your homework.